Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will look at completing the square. So completing the square is when you take a quadratic trinomial like one of these and we want to write it in this form. X plus or minus something squared plus or minus something. So how do we go about doing this? Well, let's say we have x squared plus 8x plus 10 and we want to write it in this form. It turns out the number that goes in the bracket that's being squared is always half of the coefficient of x. So the number that goes there, I need to divide by 2. Obviously, 8 divided by 2 is 4. So the reason that it's 4 is if you expand x plus 4 squared, you actually get x squared. Remember, we go 2 times this times this. 2 times x times 4 is 8x. Plus 16. So when we expand a perfect square, this number here is always double that one because you're adding it twice if you use FOIL. But see, that's the problem here. X squared plus 8x plus 10 is not the same as x squared plus 8x plus 16. So what we need to do, we sort of need to sneakily add 16 here. We can't just add 16 to something without changing it though, so we need to balance this by minusing 16. See, this here is x plus 4 all squared. This and this are equal, but we just have this little bit on the end, 10 minus 16, which is negative 6. So what we need to do is subtract 6, because that compensates that we needed a 16 at the end, not a 10. So this is the answer for completing the square. X squared plus 8x plus 10 is x plus 4 all squared minus 6. And we're done. We've written it in the form we want. So let's try something like this. X squared minus 20x plus 99. The numbers are bigger, but we won't do it any differently. So what we want to do is write it as a perfect square first up. So what goes in the brackets is half of this coefficient here. The coefficient of x is not 20, it's negative 20. So halving that, you get negative 10. So we're writing this as a perfect square. It has to be x minus 10 squared. So if you were to expand this though, negative 10 squared is actually positive 100. So we need to subtract 100 to balance this out. This part here, x squared minus 20x plus 100 is equal to this, but we've also got plus 99 minus 100, which is negative 1. And that is our final answer. If you expand this and subtract 1, you get our original expression x squared minus 20x plus 99. So why do we do completing the square? Well, you'll see later that it becomes useful in graphing quadratic equations like this, but it can actually help us with factorization. So let's say we have x squared minus 32x plus 252. Well, our method that we learned in a previous lesson, we need to find two numbers that multiply to this and add to this. Finding two numbers that multiply to 252 and add to negative 32 is not easy at all. 252 is a large number with a lot of factors. So how can we use completing the square to help us? Okay, works like this. So if it's x squared minus 32x, the perfect square part will be x minus 16 squared. So why is it negative 16 of all numbers? This number here that goes in the perfect square is always half the coefficient of x. So half of negative 32 is negative 16. So negative 16 squared is positive 256. You always get a positive when you square these numbers. So this part here is my perfect square, x minus 16 squared. So to compensate for adding 256, I need to subtract it. Otherwise, it won't be balanced. So 252 minus 256 leaves us with negative 4. Okay, so how does that help us? Well, it turns out for these ones, and even this one, we can actually factorize it further using the difference of two squares. I have a perfect square minus a perfect square. So the way you do difference of two squares, you get two brackets, square root the first. So the square root of x minus 16 squared is just x minus 16. And then you square root the second. So square root of 4 is 2. one bracket gets a plus, and one gets a minus. So simplifying that, minus 16 plus 2 is negative 14. Negative 16 minus 2 is negative 18. So that's how completing the square can help us. It would have been pretty hard for us to realise that negative 14 and negative 18 were the two numbers that multiply to this and add to this. But completing the square allowed us to bypass that. So note, you can only factorise when this is negative, when it is the difference of two squares. Here we could factorise this. We could go x minus 10 minus 1, x minus 10 plus 1. We're able to use difference of two squares here, and that just gives us x minus 11, x minus 9. We're able to do that here because it was the difference of two squares, x minus 10 squared minus 1. But you can't factorise the sum of squares. So if you end up with something like x minus 3 squared plus 9, you can't factorise this any further because it's a square plus a square. It is the sum of squares, so just bear that in mind. Alright, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.